Your motherboard has a small coin cell battery doing critical and visible work, and most PC builders never think about it until it fails. Most PC builders spend hours agonizing over their GPU, their CPU, their RAM. But there is one component that almost nobody thinks about until it is too late, and it is smaller than a quarter. This tiny piece of hardware sits quietly on your motherboard, hidden beneath cables and components, doing critical work that you never see, until the day your PC starts behaving like it is possessed. Ladies and gentlemen, meet the CR2032, a 3-volt lithium coin cell battery sitting on virtually every desktop motherboard. It is about the size of a bottle cap, costs maybe $2, and is probably hiding somewhere near your PCIe slots right now as we speak. This silver disc has been keeping your PC's most fundamental settings alive since the day your motherboard was manufactured. Now, before we go further, let's address the terminology. You might hear people call this the CMOS battery, the RTC battery, or just the coin cell. They're all referring to the same thing, the CR2032 that keeps specific parts of your motherboard alive when everything else is powered down. Different names, same component, same critical function. So what exactly does this little battery do? It has two critical jobs. First, it maintains your BIOS or UEFI settings when power is completely disconnected. Second, it powers the real-time clock, which keeps your system time accurate even when your PC has been unplugged for months. Without this battery, your motherboard would forget everything every time you pulled the plug. Let's talk about CMOs for a second. No, not the image sensors in cameras. I am talking about complementary metal oxide semiconductor. In this context, it is a tiny chip on your motherboard that stores non-volatile memory. Non-volatile means it remembers things even when power is removed, and unlike your SSD or HDD, it stores very specific, critical data that your motherboard needs before it can even start the boot process. What data, you ask? We're talking about your boot order preference. Should it boot from your SSD first, or your optical drive? Your hardware configuration settings, your overclock parameters if you've enabled XMP or manual overclocking, date and time. Sometimes even security settings like BIOS passwords. Basically, all the settings that tell your motherboard how to behave when you press that power button. Here is something important. The battery is not powering your BIOS settings during normal operation. When your PC is plugged in and running, your power supply is providing standby power to the motherboard. The battery only takes over when you unplug everything completely. Think of it like a backup generator. It sits idle until the main power fails. If you want to find this battery on your motherboard, look near the edge of the board, usually in the lower right or near the CMOS chip itself. Sometimes it is in a little socket, sometimes it is held down by a clip. Sometimes, frustratingly, it is tucked under a cable or hidden by a graphics card. The location varies by manufacturer, but it is always accessible if you know where to look. How long does this battery last? Well, here is the uncomfortable truth. Most manufacturers estimate 3 to 5 years. But in reality, it depends heavily on your environment. High temperatures can kill it faster, frequent power fluctuations. Some motherboards draw more standby current than others. I've seen batteries last 8 years. I've also seen them fail after 18 months. Now we get to the interesting part. When this battery starts dying, weird things happen. And weird is the operative word because the symptoms seem completely unrelated to a battery issue. This is why people spend days or even weeks troubleshooting problems that a $2 battery would fix. Understanding these symptoms is the key to saving yourself hours of frustration. Symptom number 1. Your system keeps forgetting the time and date. You boot up, and Windows is asking you to set the time again. Maybe it is off by hours or days. You fix it, reboot, and it is wrong again. If your battery is dying, this is often the first sign, because the real-time clock loses power before the more critical CMOS functions completely fail. Symptom number 2. Your BIOS settings keep resetting. You enabled XMP for your RAM. Gone. You set a custom boot order. Back to default. You spent 20 minutes configuring your overclock. Poof, disappeared. This is absolutely maddening if you don't know what is happening. You fix it once, and it is broken again the next day. Symptom number 3. You start seeing messages you've never seen before. CMOS checksum error, CMOS read error, BIOS configuration changed. These error codes are your motherboard literally telling you that it couldn't read the configuration data correctly, and a failing battery is often the culprit. These messages appear during post, before your operating system loads. Symptom number 4, and this is where people really start panicking. Boot failures, your system won't post, black screen, no beeps, or confusing beep patterns. You reset your RAM, you reset the CMOS manually, you try a different GPU, nothing works, you take out the battery, check it with a multimeter, and realize it is outputting 2.3 volts instead of 3. You replace it, and suddenly your PC boots perfectly. Why does low voltage cause boot failures? Because when the battery voltage drops too low, the CMOS chip doesn't get enough power to reliably store and retrieve data. The stored settings become corrupted or incomplete. Your motherboard can't read the boot configuration. It doesn't know if hardware is connected properly. It just gives up. It is like trying to start a car without keys. The engine is fine, but nothing can tell it what to do. So why do most PC builders never think about this battery until disaster strikes? A few reasons. First, it works perfectly for years, often the entire lifespan of the system for casual users. Second, when it does fail, the symptoms seem totally random. Third, it is just so small and inexpensive that it seems insignificant. We're trained to worry about expensive components, not $2 batteries. In the gaming and enthusiast community, we're constantly talking about RAM latency, CPU cache, thermal paste, PSU efficiency, but this little battery almost never discussed. Yet it can cause problems that mimic some of those expensive components failing. A no-post situation caused by a dead battery looks identical to a failed motherboard or CPU, at least until you check that $2 component. Here is something specific to overclockers. If you've spent hours dialing in a perfect CPU overclock, only to find that after a power outage or moving your PC, your system is suddenly unstable or won't even boot, check the battery before you start over at square one. Your settings might literally be gone. That stability you achieved, the battery was the only thing preserving it. Let's get slightly technical. A brand new CR2032 should read about 3.2 to 3.3 volts. As it depletes, it gradually drops. Most motherboards need at least 2.5 to 2.7 volts to reliably maintain CMOS data. Below that, you are in dangerous territory. You can test this with a basic multimeter if you are curious. Anything above 2.5 V is probably okay, but watch for declining readings over time. Quick side note, not all CR2032 batteries are created equal. Brand-name lithium cells tend to have more consistent voltage curves and longer shelf life. Cheap no-name batteries from clearance bins might work, but don't expect them to last as long. If you are replacing one, spend the extra dollar on a quality brand. It is a $2 component. Don't cheap out on the one piece keeping your entire system configuration alive. Some modern motherboards, and this varies by manufacturer and model, have improved backup capacitors that can briefly maintain CMOS data when you remove the battery for replacement. But don't mistake this for a long-term solution. These capacitors might give you 30 seconds, maybe a minute. That is enough to swap the battery safely, but not enough to run your system without a battery for extended periods. Very occasionally, you'll encounter a motherboard with a rechargeable battery instead of a disposable CR2032. These are more common in some laptops and certain server boards. They're typically labeled differently and are supposed to recharge when the system is powered, but they can fail too, and replacing them is more complicated. For most desktop PC users, you are dealing with a standard CR2032. So what is the best approach? Honestly, there is not much preventive maintenance you can do here. Batteries die on their timeline, but being aware of the symptoms can save you hours of frustration. And if your system is more than 3 years old, it is worth mentally noting that the battery might be approaching end of life. Check it before a problem occurs. Here is a cheap form of insurance. When you are doing any maintenance on your PC, cleaning dust, replacing thermal paste, adding a new drive, take a second to look at that battery. Note its position, maybe even check its voltage if you have a multimeter. A $2 battery is a lot cheaper than a weekend of troubleshooting. This takes 5 seconds and could save you hours of head scratching later. Replacing the battery is about as simple as it gets. Power down completely, unplug everything, find the battery, pop it out, pop the new one in with the positive side facing up. That is it. No drivers to update, no settings to configure manually. Your system will boot. You might need to reset your clock and date, and you'll probably need to enable XMP or any custom BIOS settings. But that is it. Anyone can do this. One thing worth mentioning, please dispose of old coin cells properly. They're lithium batteries and should be recycled, not thrown in the regular trash. Most electronics retailers and many municipal recycling centers will take them. It is a small thing, but it matters. Lithium batteries in landfills can leak hazardous materials and potentially cause fires. Do the right thing. Recycle your old batteries. A quick word on edge cases. Some motherboards, particularly in enterprise or workstation environments, have battery-free designs that use external power or store critical data differently. Some Intel NUC-style systems have removable batteries in unusual locations. Some server boards have redundant battery systems. But for the vast majority of desktop PC users, we're talking about a standard CR2032 in a standard location. If you have something unusual, check your motherboard manual. I want to circle back to something I mentioned earlier, the "it worked yesterday" problem. This is where someone builds or uses their PC. It works fine. They shut it down. They come back the next day, and nothing works. In these scenarios, people often start suspecting hardware failure, a dead GPU, failed RAM, motherboard problems. But if your system is 3 to 5 years old and you haven't had battery issues before, this is a classic sign that the battery finally dropped below the threshold overnight. Let's quickly summarize the warning signs of a dying motherboard battery. Wrong time and date on every boot. BIOS settings not saving, CMOS checksum errors at startup. Boot failures or no post after power loss, and a system that is more than 3 years old. That little battery is a great place to start before you start replacing expensive components. The CR2032 on your motherboard isn't glamorous. It is not going to improve your frame rates or make your games load faster, but it is doing critical invisible work, keeping your configuration alive when everything else is dark, and when it fails, it can make your otherwise healthy PC look completely broken. Now that you know what to look for, you are prepared. A $2 battery and 5 minutes of awareness can save you a weekend of frustration.